Hello and welcome to EC Electronics. This is an interview preparation series video of EC Electronics. Today we are going to see some questions from the embedded system area. That is some basic questions that can come from the embedded system area. We are going to discuss in this video. So there is a lot of opportunities in the embedded system field. There are a lot of people who's wanting to get into the embedded system field and they are doing a lot of courses. And for that, today we are going to discuss some questions from the embedded system area. Okay, so I have all the questions in my hand. Let us read out the questions one by one. First, if the interviewer is asking you, what is an embedded system? That is, if you are aware of the concept of an embedded system, in order to check that, if the interviewer is asking you, what is an embedded system? Then you have to answer that embedded system is actually a combination of hardware, software, and an OS. That is, it is a system combining of hardware and software. And this can be either an independent system or a part of a large system. And the major feature of this embedded system is that it is having dedicated hardware and software in order to perform a specific function. So this embedded system's job is to do a specific functionality, unless that is, it cannot be used for doing a lot of various purposes. It can be used only for performing a specific functionality, and it has the hardware and software and OS in order to perform this dedicated or specific functionality. So the main key point of embedded system is that it is a dedicated system for a dedicated job. So that is the first question. Next question. What are the various examples of embedded systems? So you should be knowing in real life what are the various examples. So in order to test that, if the interviewer is asking you the various examples, and you should be saying digital camera, ATM, then washing machine, automatic washing machine, printer. So all these things are examples you can actually point out around you that are actually embedded systems. And if you think about these systems, they are actually used for a specific functionality. In order to wash clothes, we are using a washing machine. It cannot be used for a general purpose. It is a specific function. For example, a printer, it is only for taking out printouts. Okay, so that is the various examples of embedded systems. Okay, so there are a lot of other examples also. If you Google it, you can find out. Anyway, surrounding you, these are some examples. Okay, next question. What is the difference between computer and an embedded system? So we can say computer as a general purpose system, whereas embedded system is something different. So while discussing about the embedded system, we are always saying that it is used for performing a specific functionality or a dedicated function, whereas computer we can use for designing of various programs or various applications. We can actually design with the help of a computer. So it is called a general purpose system, whereas an embedded system is something different from it. It is used for a dedicated functionality or in order to perform a specific function. So that is the key difference between a computer and an embedded system. Next question. What are the various components of an embedded system? So if you generalize or generally categorize the components of an embedded system, you can say it is hardware components, software component, and an operating system. And all these components, hardware, software, and the operating system, mostly this operating system will be real-time operating system, that is RTOS they'll be using. Okay, so this hardware and software is dedicated for performing only the functionalities of the embedded system, not for a general purpose software or general purpose hardware. They won't use only the required amount of hardware and software they'll be using in the embedded system. So some examples you can say it is timer, IO, the processor, memory, etc. are the various hardwares, and the softwares are solely dedicated to perform that specific function. So it consists of generally hardware, software, and an operating system. So like in any other system, the operating system's functionality is to coordinate this hardware and software. So you should be aware of these things. Next question. The difference between a microcontroller and a microprocessor. Now, why this question is relevant? If you see the questions, interview questions of any of the embedded systems on various sites, you can find this question. Now, what is the relevance of this question? Because in some embedded systems, they are using microcontroller. In some embedded systems, they are using microprocessor. Now, what is the main difference between this? A microcontroller is a single chip consisting of all the peripherals, memory, everything is included in a single chip. Then we call it as a microcontroller. Whereas a microprocessor consists of only the ALU, the stack pointer, PC, and clocking unit. Only these things are present on a single chip. The other peripherals, whatever we need, we have to add externally to this chip. So only then it forms a complete system. So such a device or such a system is called a microprocessor. Whereas in a microcontroller, all these peripherals, memory, and everything is included on a single chip. So that is a basic difference between a microcontroller and a microprocessor. Okay, so I have included also an image differentiating these two, microcontroller and microprocessor. So please do have a look in order to understand more about the architecture of this. What is the difference between hard real-time system and soft real-time system? This is also very useful, very commonly heard question. So we have discussed that in a embedded system there is a hardware, there is a software, and there is a operating system, which is 90% of the time it is a real-time operating system. Now this real-time operating system can be categorized as hard real-time operating system and soft real-time operating system. Now a hard real-time operating system means it is having a very critical deadline. Means in what is actually a real-time operating system? Real-time operating system means they are operating systems or OS giving more importance to time. That is, there are certain functions or there are certain processes we do with the help of operating system, right? So if these processes are time bounded, that means if there is some deadlines given to these processes, and if the operating system is giving more importance to the time or the deadline, then such operating systems are called real-time operating system. So the time is very important in those real-time operating system. Whereas in other operating systems, that is, whereas in general other type of non-real-time operating systems, the performance is important. The time is not important. However time it take, if the performance is good, then such type of operating systems are called non-real-time operating system. Okay, so the examples of real-time operating systems you can see as Unix, Linux, Ubuntu, etc. are various real-time operating systems. Now, this real-time operating system, that is the operating system which give importance to time, can be categorized as two: hard real-time and soft real-time. Hard real-time means if the deadline is missed, then the system crash can occur. That is, some catastrophic problems or some deadly problems can occur if the process is missing its deadline. Then such RTOS or real-time operating systems are called hard real-time system. So we cannot even think of missing a deadline in a hard OS or hard OS system. Whereas in soft real-time operating system, even though the process is missing the deadline, the performance of the system is degraded. Nothing much serious is not going to happen. Okay, so such type of operating systems are called soft real-time operating system. So these are the two categories of hard real-time, that is categories of real-time operating systems. That is hard real-time operating system and soft real-time operating system. So if you want me to do a detailed video on real-time operating systems, introduction or any topic from this RTOS, please do mention in the comment section. We'll be doing a video. Okay. So anyway, if you have to face such a question, you should be answering this. If the time is very important, if something deadly will happen, if the deadline is missed, then such operating systems are hard real-time. And if even if the deadline is missed, no serious issues is going to happen, means that is soft real-time. So the word also indicates soft and hard. Okay. So that is a difference, or that is a category of a hard, that is a category of a RTOS. Next question. Differentiate testing and verification. So what is testing and what is verification? So while designing an embedded system, there is a design cycle of any systems. Likewise, there is a design cycle for an embedded system also. So while designing the life cycle of an embedded system, During the designing stage itself, a verification is done in order to check whether the system can function right or any problems will happen. So for that, we include a verification stage in the design cycle of an embedded system. Okay, so for example, a printer. During the designing of a printer, we include a stage called verification stage, in which we are going to check whether we are going to check the system logically, that whether the system will function as it is, that is the way it is designed, or such a stage is called verification stage. That is, this stage is actually happening before manufacturing of your embedded system. Say it is a printer. And what is difference between the testing? In testing, if the testing means it is happening after the system has been designed, that is after the system has been manufactured. If the testing of the device is happening, means that is actually called testing. So if the verification, if we are talking about the verification stage, means that is happening before manufacturing of your embedded device. Okay, so that is the difference between testing and verification. Next question. What is a device driver? So this is a very, very important question. So we have seen a lot of, we have heard a lot of things about device drivers. There are various device drivers. Now, what is actually a device driver? Device driver means these drivers or these programs or these softwares are actually used to drive the device. For example, if you are connecting some hardware device to your computer, there will be some icon showing in the bottom menu. That means first the system will ask for the permission in order to connect the device. Then, in order to operate that external hardware device properly within your computer, some software should be there to interface between this computer and the external hardware device connected. So this software is actually called the device driver. And the function of this device driver is to make the hardware device which is connected to your computer or your system to function properly. So in order to make the functioning of your external device proper, some device driver or some device program has to be installed in your systems. That is called a device driver. So it is actually acting as an interface between the computer and the external device. So I hope it is clear. Next question. What is a watchdog timer? So this is also very, very important if you are studying microcontroller or microprocessor or any that processors or controllers, and also for embedded systems. Now, watchdog timer is actually an electronic timer which is designed in order to ensure the safe working of your system. So what will happen is that this watchdog timer has a periodic timeout. So while the system is functioning normally without any problems or any crashes, the system will itself reset this timer within this timeout period. So consider that some clashes happened or some problems happened within the system, and the system cannot reset this watchdog timer, means it will generate a timeout signal, and this timeout signal is to make the system aware that some problem is happening or some clashes or some errors is happening. So the watchdog timer is actually designed to ensure the proper working of the system without any problems. So when some problem is happening, means it will go to the timeout stage, and some system recovery programs are included within that routine. Okay, so in order to make the system work properly, watchdog timer is used. Okay, so that is the answer. Next question. What is the need for infinite loop in embedded system? In embedded systems, the infinite loop is actually for monitoring some parameters of the system. For example, consider an automatic chocolate vending machine. Okay, so whenever the user is going to insert the coin, the device is going to give that particular chocolate. That is a chocolate vending machine. Okay. So in the case of a chocolate vending machine, the system has to repeatedly monitor whether the coin is being inserted, and whether the user is inserting the coin, or whether the user is selecting some option. So in order to have this monitoring an infinite loop is running, always checking whether some coin is being inserted into the slot. And also it has to check whether the coin inserted is properly, or the coin inserted is having the correct amount. And for all these things, it has to infinitely check for the parameters, or it has to repeatedly monitor the insertion of a coin. This is a very simple example. In all other embedded systems, there are infinite loops designed or kept in order to monitor some parameters or some changes that can happen within the system. Or also, if the system is anticipating some errors, in order to check whether the error is happening or not, there are infinite loops kept. Okay, anyway, so the infinite loops are actually kept to monitor some parameters or some changes that can happen in the embedded system. So these are some questions. Why would someone choose to use an embedded system over the other available options? I'm basically reading the questions and answers, or the questions from the laptop. That's why I'm looking down. Okay. So why would somebody choose an embedded system over other systems? The answer is, if you are looking for a very specific functionality, if you are interested in going for a very specific functionality like ATM, or for example, digital camera, you just want to take photos or videos. If it is a specific functionality, then if you want it to be an optimized, like a compact system, and if you want that system to run for longer time with more power, more like this, less power consumption, or it optimizes power, and if you are looking to optimize the cost based on the requirement of hardware and software, then that is a scenario in which you will be going for an embedded system. Okay, so embedded systems, we all know that it is a application specific system. It has a specific application. It is used for a specific application. So if you are looking for such kind of an application, for example, washing machine, it is used for washing clothes. That is the only thing. It doesn't do anything else. Or if it is like an ATM, it's used for taking money from the bank, that is the transaction, or taking off money. That is the only thing. So it's like optimized for that. It uses less power, or the power storage is optimized. Hardware and software is optimized for that specific functionality. So if these are the things, if you are looking for this kind of things or this kind of applications, then that is a very good point in which you can go for a embedded system. That should be your answer. The next question is, when might an embedded system require an infinite loop? Okay, so we know that in embedded systems like ATMs, there is a message always being run in an infinite loop unless and until a user comes in and user insert the card, then the message changes. So there is an infinite loop running to always welcome the user, or to display some advertisements. Those kind of things is there. Or if you take an example of a video game, okay, a video game or a PlayStation, that can also be called as a embedded system. So in that also, an infinite running of a game is happening unless and until you switch off it, unless and until you do anything else, the game will be running in an infinite loop. Okay, so these are some scenarios in which infinite loops, that is, if some operations need to be repeated for a longer period of time without an interrupt, or without actually a monitoring from the operating system, then that kind of functionalities we put in an infinite loop. That is, the things or the steps or the process that we want to run continuously, we put in an infinite loop. Whenever some other specific things happens, for example, somebody comes in, somebody insert the ATM card, or some other things, like some other specific operations is happening, until that this loop will run. Okay, so if you want some steps to be run for a longer period of time, like for forever, if you want that to run, then you put it in a infinite loop. Basically, in all programming languages, we do this kind of things. For example, if you want some loop to run and it shows options for the user should select options from the given set, like from 1, 2, 3, 4, 5. if there is some prompt asking the user to select an input, then that also runs in an infinite loop. So these kind of things we always put in whether it is in Python, whether it is in Java, C, C++, everything, we use either while loop or some other loops to run continuously as an infinite loop. Okay, so you can pick examples from the scenarios that you see in your real life. So that will be the answer for when you are using an infinite loop in an embedded system. Let us move to the next question. It is like a question that you can relate in your real life. Okay, now what are the different types of embedded system, and with which one do you have most experience? So this is the third question. You can see the questions on the screen. Okay, so what are the different types of embedded systems? Like you just give some examples of embedded system, and what are the ones that you have most experience with. So it is asking, so the interviewer is basically asking you to pick some examples from your real life scenario. You can say washing machine, you can say digital camera, you can say printer. Very, very good example. Printer is like very common thing in like households or everywhere now. Or you can say ATM. It's like inevitable for everybody because we all need money. Then automatic vending machines, chocolate vending machine or soda vending machine, whatever. Like you can see these kind of equipments in like for example railway stations or some, like everywhere now. You just insert the coin and you get like candy or some food or even magazines now. So it's like a very common thing which you interact every day. I would suggest you say like a washing machine or a digital camera or a printer or an ATM. These are very like day to day we have interactions with these kind of embedded systems, and all these are embedded. So if you don't know the examples of embedded system, I have listed out a long list of embedded systems now. And there is more of it. I think I have made a shorts or a small video on like different types of embedded systems. But anyway, if you don't know, then this is the answer. Okay. Let's move to the next question. What are the different levels of testing in embedded system? Okay. So the different levels of testing is basically 4 levels of testing is there. Unit testing. Unit testing means it is testing different units, like unit by unit it is testing like the parts of a system, basically an embedded system. Integration testing, you try to integrate the units together and you test it. Then system testing, you are going to you get a system when you integrate them, and you are going to try the or you are going to test the system. Next is user acceptance level testing. So basically when you are trying to operate it as an actual system, like when a user comes, when the user interacts with the system, how the system is behaving, you want to know how the system is behaving, then that level of testing is called user acceptance level testing. So these are the 4 levels of testing. There can be sub levels, but mainly these are the 4 levels. While all these levels are important, the user acceptance level testing will help us to understand whether it gives a specific functionality which we are actually making it for. As a company, if I'm making an embedded system, I have certain set of outputs which I'm expecting from the system, certain level of performance, certain level of certain things that I expect it to do. I have some expectations level when I'm thinking or when I'm deciding when I'm designing the prototype. So if it is behaving in that way based on my expectation, it's actually understood in the user acceptance level testing. Okay, so that is the question, and you can answer it in this way. Now let's talk about the ISR or interrupt service routine. The question is this: do you know what ISR stands within the context of an embedded system? What does it do? So ISR, if you don't know, it is interrupt service routine. That is, for example, if you are say if you are trying to take money from the ATM, okay, and suddenly you understood, okay, I need some more money, like the money that I've entered is not sufficient. I need to stop the transaction in between while I am doing something like some calculations, or when I split the money into like how much notes I want, whether I want 100 rupee notes or whether I want, it's it's basically doing the transaction, and while I am deciding, okay, I need more money, so I need to interrupt, I need to stop the transaction, I want to start it again. So in that case, you just press the red button, or you just push the reset button. That is actually acting as a ISR, or interrupt service routine. And what it does is, so earlier the operating system was processing a set of instruction to do the money transaction, but suddenly you press the button, you press the reset button, then it understood, okay, I need to stop this. So the normal flow of executions is stopped in between. So this process is called interrupting. Basically, when somebody is talking, if you are talking in middle, that is called interrupt. We say that, okay, don't interrupt, or normally we say, right? So this is also the same meaning when it comes to these kind of operating systems, or when it comes to embedded system. When the processor, or when the operating system is doing or processing set of instructions, while you ask it to do something else, or you need to stop it, or you need to do something else in between that, then you go for a interrupt. Then you raise an interrupt by either pressing some buttons, and that is called a interrupt. And this process, or this whatever you are whatever you want to do now, that is called interrupt service routine. So when an interrupt comes, what happens is operating system will stop whatever it is doing right now, and it will try to process the interrupt, because interrupts have like more priority based on like levels of priorities. Actually, it's like a deep topic. Every interrupt has a set priority, and it is a design time decision, like which interrupt should be given highest priority, which interrupt should be given lowest priority. So you already write those things in the code. So when an interrupt of this behavior comes, the operating system will stop whatever it is doing, and it is going to process the interrupt. So that is an example of interrupt service routine, and it is basically asking an assistance when operating system is doing something else. In a very normal language, we can say like that. Okay, let us move to a basic question. I am 100% sure you are all aware of this. Define the components of an embedded system. So there are a lot of components. If you go into the basic things, there are different components for an embedded system, and based on the requirements of the application for which you are designing it, it also varies. Now, an embedded system consists of primarily three components. Hardware is required, software is required, and operating system is required. Hardware is always application specific. As I said, all embedded systems are application specific. Like it is designed for set of, or not a set of, for a specific application. It just want, that is when somebody is designing it, the person want it to do only something, not everything. Okay, so hardware is also selected in that way. Now, application specific hardware is selected. If it requires a switch, it is included. If it requires some other things, for example, a part to give the coins or take the money, then that is included. Or if it wants some IOs or input outputs, or if it wants some timers, or if it wants a display, only then that is included. Otherwise, it is not included for general purpose. That is the first part, which is hardwares or hardware. Then software is also very specifically designed for that application. It's not a general purpose software. It is an application specific software. Third part is real-time operating system, or RTOS. So we have actually made a set of videos on real-time operating systems. I have actually made interview questions on that too. All of this is in the channel. A lot of people are actually not aware of our videos. I don't know why, but okay. If you are somebody who is new to this channel, please try to share the videos with the friends or family or colleagues or whatever. Okay, so the third component is operating system. Operating system we are using here is real-time operating system. So these kind of operating systems, which is real-time, they are called, why they are called real-time is because they give a lot of importance to time, deadline. Every task should be finished within a given time. The time is very important. That kind of operating system which gives importance to deadlines, time, that is called real-time operating system. Okay. So the first question that we are going to see is, what is the difference between von Neumann architecture and Harvard architecture? Okay, so while I'm explaining the answers, you can see the images and all on the screen. Okay, so this is a question which is connected with the architecture. Okay, so if you have studied architectures of various processors, you have heard the term von Neumann and Harvard. So here the basic difference lies in between the arrangement of memory. In von Neumann architecture, it is considered to be a little bit older version. Harvard is little bit organized, more organized, and it is considered as more good, and it is having high performance. Okay, so the basic difference is in the memory arrangement. In von Neumann architecture, there is only one single memory unit. In that, we are storing the instructions and the data together. That is, there is no separation as data memory or an instruction or program memory. Both are being stored onto a single place. Okay, and this data and also instructions we are accessing through a same bus. Okay, so what is the main problem in going for von Neumann architecture is that when we are storing the data and instruction, everything together on a single place, there can be congestion. Also, since we are using a single bus, there can be latency. So these are some problems connected with von Neumann architecture. Now coming to the Harvard architecture, here there is actually a partition in the memory which actually separates data memory from instruction memory. Okay, so program memory or instructions are stored in a separate place and data is getting stored in a separate place. And there are two different buses which is used for accessing these two parts. Okay, so due to this good arrangement, you can say there is low latency and also congestion problems can be avoided. So these are the basic difference between von Neumann and Harvard. What is the difference between firmware and software? We generally use these two terms, but what is actually the difference between a firmware and a software? Okay, so first talking about the software, it is a set of instructions which is being written or installed in a computer or any system to control it or to enable certain functionalities. Okay, so here the user can interact with it, can change it. So once it is been installed or written, user is able to interact with it and can change it. Okay, but talking about the firmware, it is actually a set of instructions which is used to control a specific part of a system. And here the main difference is that once it is been written or once it is been installed, it cannot be changed. Okay, the user is not interacting with it. Now talking about embedded systems, mostly they are having firmwares. For example, if you are having a printer or any embedded system, mostly they'll be programmed at the time of manufacturing itself, and we are not reprogramming it every time. Okay, we are just using it. We are not programming the device every time we are using it. So firmware is being installed or it is being used in these type of embedded system most commonly. Okay, so this is the difference between a firmware and a software. Next question is, what are device drivers? Okay, so device drivers are set of instructions or files which will help a hardware device to communicate with a computer's operating system. For example, when we are connecting a new hardware to your computer or laptop, you can see that some program is getting installed into your computer. So that is actually the device driver, which will help the communication between the hardware. For example, if you are connecting a pen drive or a USB, so that will help in the communication between the computer's operating system and the pen drive. Okay, so there should be some medium for the communication with the external hardware and the computer's operating system, and device driver is making that communication smoother. Okay, so that is the basic idea about device driver. So it is actually set of instructions or files which will help any device getting connected to the computer to communicate with its operating system. Okay, so that is the basic functionality of a device driver. Okay, next question is actually a little bit application oriented. So we can take two things. First one is a printer, second one is a computer. Okay, so printer is an embedded system, whereas computer is a general purpose. Why is that? Okay, so how is printer embedded and computer general purpose? Talking about a printer, so printer is designed to perform only a certain function which is called taking of printouts, right? But for the case of computer, we can actually program it to perform n number of functionalities. So it is called a general purpose system. Okay, so printer has a specific functionality, that is why it has been categorized as embedded, whereas computer is a general purpose system which can be, we can program it every time when we need to have some functionality. It is programmable, right? So that is the basic difference between an embedded system and a general purpose system. So all embedded systems, if you take the example of an automatic chocolate vending machine or an ATM, or you say a digital camera or an automatic washing machine. So all these things are application oriented. So every embedded system is application oriented. They are designed to perform a specific functionality, whereas computer, it is not really performing a single functionality, but it can be programmed to perform any functionalities which is possible. Okay, for example, if you want to watch some movie, it is possible. Sometimes if you want to install some softwares, for example, if you want to do some processing in MATLAB, you can install it. So just like that, it is programmable to perform a number of functionalities. So that is why it is general purpose, whereas printer, which is a specific functionality, it is having a specific functionality and it is embedded. Okay. Next question is, what are the various types of embedded systems? Okay, so the first classification lies in based on the real-time embedded systems. Okay, so real-time embedded systems can be classified as hard real-time and soft real-time. So I have explained about what is RTOS and why RTOS is being used in embedded system in the part 1 video. So you will get a clear explanation there. So anyway, just understand that an embedded system is having operating system. Mostly that will be RTOS only. The RTOS means real-time operating system only. Okay. Now this RTOS or real-time systems can be classified as hard real-time and soft real-time. Okay. So if the application for which we are using the embedded system is critical one, then we go for hard real-time. Whereas if you are using it for some commercial purpose, then we will be using soft real-time. So this is one classification. Again, the embedded systems can be either networked ones or it can be standalone. Means it will be either connected with some other systems, means it will be a part of a bigger system, or sometimes they can be standalone, just like printer or washing machine. Okay. Then mobile embedded systems and immobile embedded systems is there. And based on the performance of the system, we can classify it as small scale embedded system, medium scale, and complex or sophisticated embedded systems. Okay, so these are various classifications of embedded systems. Next question is, what are some applications of embedded system? Means some areas in which we use embedded systems. Okay, you can actually point out all the examples which we see in our daily life, just like a washing machine or printer or ATM, or you can say automatic chocolate vending machine or soda machine, or you can say ATM card, digital camera. These are various examples of embedded systems, or you can say dishwasher. Okay, so these are some applications of embedded systems itself. Other than that, also use embedded systems as a part of a bigger system. For example, in your vehicle, you use this automatic braking system to apply brake on the vehicle if it is exceeding a certain limit. Okay, to avoid accidents and all. Okay, so these type of applications is there, and also we use certain embedded system for home automation purpose. Okay, so there are various applications of embedded systems in real life. Okay, so you can point out all these examples as applications of embedded systems. The next question is, what is a bootloader in an embedded system? Okay, so the bootloader is the piece of firmware, or it is the instruction that is first getting executed when the system is either turned on or it is being reset. Okay, so the first instruction or the first firmware which is getting executed, and it transfers the control to the operating system, that is the real-time operating system. Okay, so the first set of instructions that are getting executed is called the bootloader. Its function is to transfer the control to the operating system present in the embedded system. Okay, so that is the functionality of a bootloader. The last question is, why embedded systems are useful? Why are we going for embedded systems? We are having general purpose systems. Then what is the purpose of going for an embedded system? Okay, so this is a very important question because this is actually explaining about the importance of embedded systems itself. Okay, so why are actually we going for this concept? What is its application? So main purpose is application specific itself. Okay, see, in order to execute a single functionality, we don't need a general system which is programmable for various functionalities. We can go for a application specific system, and by doing this we can actually replace a lot of unwanted hardware and software from the bigger system, and we can actually reduce the size, and various gates and buffers and everything can be reduced from the system. Okay, and hence we can actually create, or we can make a system which is very much application specific. Okay, so that is the main functionality of going for an embedded systems. Okay, so here we are designing a system which will perform only one specific function. It cannot be programmed once it is being designed. Okay, or once it is being created, it cannot be programmed further because it is meant to perform only a single functionality. That is the main use, and that is the main importance of going for embedded systems. Okay, so which of the following offers CPUs as integrated memory or peripheral interfaces? This means that which of these that is out of the given options which is having integrated memory and peripheral. Okay, that is CPU will be having integrated memory and peripheral. Now, if you know the architecture of microcontroller and microprocessor, the differentiation between these two, you should be knowing that in a microcontroller, so if you see the microcontroller, you will be having all the things integrated onto a single chip. There will be memory units, there will be peripherals, there will be processors, everything will be integrated to a single unit. RAM, ROM, everything. The RAM, peripherals, everything will be integrated onto a single unit. Okay. Whereas for the case of a microprocessor, only the processor will be as a single unit, and the other elements, that is the peripherals, the IO, everything we have to connect externally. So that is a basic difference between a microprocessor and a microcontroller. So you should be knowing this as by heart. Microcontroller means everything will be in a single, it is a controller. So everything will be inside that single chip or single board. Whereas for a microprocessor, only processor is present. Other units we have to add externally. Okay. So here the question is asking which of the following CPUs has integrated memory and peripherals, means it is option A, that is microcontroller is the correct answer. Okay. Moving on to the second question. So in when you are studying for embedded systems, or when you are studying the embedded system topics, you should be actually studying this microcontroller, microprocessor, everything, because the embedded systems mainly deals with these type of processors. Okay. So the second question is, the initial routine is often referred to as dash. A, initial program. B, bootstrap program. C, final program. D, initial embedded program. So I hope that you have heard of this term called bootstrapping or bootstrap program, which is actually the instantiation routine or the initialization routine. Okay. So whenever we are starting the computer, the first thing that is getting loaded is called, first thing that is running is called bootstrap program. Okay. So the correct answer is B, that is bootstrap program is the initial or the initialization. It is actually called the initialization routine. It initializes all the other things, the operating system, everything it is initializing. Okay. So the answer is option B, which is bootstrap program. Third question. Which one of the following is UV erasable? That is, which of the memory is UV erasable? I'll read out the options. A. Flash memory. B. SRAM. C. EEPROM. D. DRAM. Okay. Correct answer is EEPROM. EEPROM means it is erasable programmable ROM. EEPROM means E stands for erasable. P stands for programmable. So, here the erasing actually is done with the help of UV rays. Okay. So, which of the memory is erasable with the help of UV rays? Correct answer is option C. Okay. So, correct answer for the third question is option C. Next question. Which type of memory is suitable for low volume production of embedded system? That is, when you are producing a low volume type embedded system, which of the memory is suitable? That is a question. Okay. A. ROM. B. Volatile. C. Non-volatile. D. RAM. Okay. So, we can go for non-volatile memory. Whichever non-volatile memory is present, you can go for that memory. Because when you are producing a system which is of low volume, then if you are using a non-volatile memory, the device which is having a non-volatile memory will allow the software to get downloaded into the system and it can be retained within the device. Okay. So, you can go for a non-volatile memory. That is the best choice. Okay. So, it can be used for low volume production. That is, this non-volatile memory can be used for low volume productions. Okay. Correct answer is C. Next question. 5. Which architecture in digital signal processor reduces the execution time? Okay. A. Harvard. B. CISC. C. Program storage. D. Von Neumann. Now, I hope that you have heard of these terms, Harvard memory and von Neumann. So, we have actually discussed regarding these two type of memories, or it is not actually memory, it is actually architectures. Okay, architectures while discussing the microprocessor initial videos. Okay, so there are two type of organizing a architecture of DSP. It can be Harvard architecture or it can be von Neumann. Okay, these are the two methods, two basic methods. Okay, in the case of a Harvard architecture, the memory has no partitions. Sorry, the memory has partitions. It is divided into data memory and program memory. Whereas, in the case of von Neumann, if you see the memory organization, both the memory, that is data and program, are being stored into a single space. There is no partition or nothing. So, here, when you are going for the von Neumann architecture, you can have a bus for taking the program and data, and there can be congestion because a single bus will be mostly taking the program and data, so it cannot be fetched together. So there can be sometimes congestion problem also. But when you are going for a partition like this, that is when data is stored to a particular space and program is stored to another space, you can have a differentiation between these two. And here, when the processor, so the processor will be accessing this memory, right? That is, the processor will be taking the data and also the program. So when this type of arrangement is being followed, what happens is that it is more orderly and it will reduce the execution time. Here, there can be congestions, there can be collisions in the bus and all those things will happen. Okay. So this is a more orderly arrangement of memory. It is more suitable and it also reduces the execution time. So the correct answer is Harvard architecture. That is A, Harvard is the correct answer. Okay. Correct answer for the fifth question is A. Okay, so this is the differentiation between Harvard and von Neumann. The main difference is that there is a partition or a separation for data memory and program memory in Harvard, but in von Neumann, which is a more a primitive kind of architecture, here both the memories, that is program and data, is stored to a single space. Okay. So correct answer for fifth question is A. Next question. That is the sixth question. Sixth question is, which forms the heart of the operating system? Very basic question. Okay, so when I'm reading the options, you'll be getting to know the answer. Okay. Which forms the heart of an operating system? A, kernel, B, application, C, hardware, D, operating system. So the heart of the operating system, heart or core of an operating system is called kernel. So this kernel can control the hardware and can deal with the operations of interrupts, IO system, memory and everything. So mainly all important operations or processing is done with the help of a kernel. Okay, so if you see the OS, the heart or the core is called kernel. Okay, so this is the operating system. Correct answer is A. Okay. Next question. Seventh question actually. Okay. Which of the following languages can describe hardware? Okay. So it is again a simple question but a little bit thinking type of a question. If you are familiar with this thing, then you should be answering in like 1 second or something. Okay. Which of the following language can describe the hardware? A, C, B, C++, C, Java, D, VHDL. Okay. So hardware description language means HDL. It is VHDL. Okay. So VHDL is the hardware description language. That is, in VHDL, if you see the difference of VHDL from other languages are high level type of languages, whereas VHDL is a hardware oriented language. Means here we are actually writing the program in terms of the hardware, whichever port we require, whichever elements we require from the hardware, that hardware specific code we are actually writing. Okay, so we just need to burn to that hardware. Okay, but for the case of other languages, they are actually more human understandable form. Okay, and those languages has to be converted to machine understandable form, and then only we can burn to the hardware. Okay, so here also we are required to compile and all, but more it is concentrating on the hardware. That is, whichever hardware you are requiring, this much of ports you require, this much of pins from the hardware you require, that type of coding is called HDL type of coding. That is hardware description language type of coding. Okay, so out of the given options, C, C++, Java are more higher end languages, whereas VHDL is a hardware description language. Correct answer is option D. Okay, next question. That is the 8th question. Which of the following allows the reuse of software and hardware components? Okay. A, platform-based design, B, memory design, C, peripheral design, D, input design. Okay, so when we are going for a platform-based design, the platform-based design allow the reuse of hardware and software components. So in order to cope up with the increase in the complexity of the embedded system. So when we are adding some of the new elements, or when we are going to increase the complexity of an embedded system, if you are going for a platform-based approach, means we can have that complexities or we can have that additions. Okay, so the hardware, that is the platform-based design, will help in the reuse of the hardware and the software components. The correct answer is option A. Okay. Next question. Which design activity is in charge of mapping operations to the hardware? Okay. A, scheduling. B, high-level transformation. C, hardware software partitioning. D, compilation. So when designing an embedded system, there is designing of hardware and designing of software. Okay. So actually sometimes we also go for a like mixed kind of a thing. Hardware, software, co-designing. It is also possible. So whenever we are designing this embedded system, in the hardware software partitioning, we decide that which all things need to be mapped to the hardware and which all things will be kept in the software. Okay, so that partitioning will decide the mapping of operations to hardware. So there will be some hardware elements, there will be some software routines. So when we are doing the hardware software partitioning, we decide that these all routines are more concentrating on the hardware. Okay, so the hardware software partitioning is activity which is in charge of mapping the operations to the hardware and also to software. We decide that in that partitioning, we decide that this will be going to hardware and this will be kept in the software module. Okay. So correct answer is C. Then 10th question. So very basic question. So also you should be knowing the answer of this question. Okay. So the question is, embedded systems are dash. A, general purpose. B, special purpose. C, both A and B. So which of this option is correct? Embedded systems, if you don't know about the definition of embedded system, I would suggest you to watch two videos. In the interview preparation playlist of Easy Electronics, you can find two videos on embedded system interview questions. In the part 1 video, I have actually explained regarding the basics of embedded system, what is embedded system, what all elements are present in an embedded system, everything. Okay. So it is, when you talk about an embedded system, it is a system which is designed for a specific purpose and it is only intended to do that purpose. It is not general purpose like computer. So if you talk about a computer, it is a general purpose system. We can make use of a computer to perform a lot of operations. But if you take the case of a printer or a washing machine or some other modules, for example, an AC or a printer, okay, if you take a digital camera, all these things are meant for performing specific operations. For example, if you take a printer, it can only take printouts, right? So it has a specific function, right? But general purpose system means like computers, they can be make use to do a lot of applications and everything. But an embedded system like printer or a washing machine can be only make use to do only a specific thing. Okay, so that is the main difference between embedded system and a general purpose system. The examples of embedded systems are, you can say it is printer, washing machine, then ATM, then video camera. These are actually very basic embedded systems which we daily see. So that's why I've told there's a lot of embedded systems if you search for around us. Okay, so anyway, it is a, what type of a system? It is a specific or a special purpose system. Correct answer is option B is the correct answer. Okay, so these are the 10 questions which I have included in this video. But anyway, I would suggest you to watch the video on the interview questions from embedded systems also. There are two videos which have been kept in electronic core company interview preparation playlist. I would list out that playlist in the description also. So you can find that video. There are two videos. Just listen to those videos. Okay, you will get a very good idea regarding embedded systems and that will be useful for your examination also. Okay,